Okay, good afternoon. I will actually complete the lesson for the limit today, and of course, it doesn't take more than 30 minutes at most. And then you are supposed to work the rest of this session and next Tuesday so that we can have the exam on Wednesday. And I have already updated the Google Classroom for which problems in the miscellaneous problems you are supposed to work on. Okay, and there are two chapter tests at the end of this chapter. I have also mentioned which problems you are expected to know. Okay, and then of course I will update the Google Classroom once more. Whatever I have written on the Google Classroom from the beginning till the update that I will do today after the lesson is what will be included in the exam. Yes. So because I remember you were a little bit confused last year about the way that I mentioned that, I want to make sure that you understand what's going on. Okay, so there are two things that I want to do in this short lesson is to give you a little bit more examples about calculating limits, and then talk a little bit, because that's not part of your lesson that much, talk about the limits when the answers are infinity. Okay, that's it. Okay, so let me start with this example. So determine the following limits. Okay, so number one, so I will emphasize a little bit on the ones which we have search signs. Yes, so for example, we want to calculate the limit of x squared minus 4 divided by square root of x minus, so let me make this 16, and then let me make this one 2, and I would say x goes to 4. Okay, so let me just concentrate on the tricks today. So the first thing you need to do, you want to calculate the limit, you put the number in. If nothing strange happens, everything is okay, that will be your number. Otherwise, you need to think what to do. Okay, so in this case, I put 4 in the numerator, it becomes 0. From now on, when I say it becomes 0, it's a sloppy language. I mean it becomes very small. Because if x is exactly 4, then x to power 2 becomes exactly 16, minus 16 is exactly 0. But this symbol, I already told you, means even though I am very, very close to 4, that one thing is clear, I am not equal to 4. X is not equal to 4. When x is very close to 4, not equal to 4, x squared is, of course, close to 16, but not equal to 16. So the difference is not exactly 0, it's a negligible number. The terminology we use, we say it's an infinitesimal, yes? So anyway, from now on, I would say it is 0, I mean this. And I would do the same thing for the denominator. The numerator being 0 doesn't pose any problem. But when I put 4 here, square root of 4 is 2, 2 minus 2 is 0. Again, infinitesimal is 0. Then I'm in trouble. So, and I told you that if you have infinitesimal divided by infinitesimal, which in literature people sometimes use a sloppy language to say 0 over 0, is indeterminate. And you have to get rid of these indeterminates. Okay, so these are the things that I discussed last time. What should we do? This one you already know what to do. So the goal is to factorize that. But if you have something containing a search sign, you have to get rid of the search sign in that location. If it appears in the numerator, you should get rid of it. Of course, the price that you will pay is to have it in the numerator. If it is in the numerator, you need to get rid of it in the numerator, but of course the price will be that this will appear in the denominator. Okay, but this is very interesting gymnastics because you can immediately solve the problem. Let us see why. Okay, if I want to solve that problem, remember, don't be lazy, especially in the exam. You have to write this limit x goes to 4 until the very last step. For x squared minus 16, I know what to do. So I write x minus 4, x plus 4. And then I would write the denominator square root of x minus 2, but for getting rid of this square root sign in the denominator, I told you the trick. You have to rescale it in a way that by the conjugate of the third one, the term with the one containing the third sign. So square root of x minus 2, its conjugate is the square root of x plus 2, and I divide it by the same thing, by the same number. So this is another fancy name of 1. 1 multiplied by everything is the same thing. So hopefully you realize I can still keep this equality because I haven't done any changes. I have just written this in a different form. Okay, but this will be helpful. Why? Because if I multiply the numerators, so I just juxtapose them, don't spend time at all in multiplying them, okay? Just put them next to each other. But for the denominator, I intentionally made it a conjugate rule. And the answer now becomes simple, yes? So this one multiplied by that becomes the first one squared, which is x, minus the second one squared, which is 4. And then x goes to 4. Okay, now you see that x minus 4 and x minus 4 are cancelled. Why can I cancel that? First of all, because that's a common factor for numerator and the denominator. Secondly, this symbol guarantees that x minus 4 is not 0. It's very small, but not 0. Okay, so I can just safely remove that. And then what is happening? Again, you see I am just writing this symbol, limit, and then I have x plus 4, square root of x plus 2, and x goes to 4. So I am not claiming that this function is equal to this function, but I am claiming that the limit of this function is equal to the limit of that function. The reason is that when x is not equal to 4, the values of this function match with the values of this function if x is not equal to 4. And in this limit, I am not interested I'm not interested in what happens at exactly 4. I am interested to know what happens for my function at points very close to 4. Yes, please.
Will we be writing the exam on paper or in?
I haven't decided yet, but I will do that.
Because if it's in exam.net, can you show us how we write limit and x approach?
No. Even if this is on DG exam, for those questions that you have to write, I give you access to pen and paper. Might be only the questions are there. No, typing them is actually killing your focus because you cannot concentrate on solving and typing in the same time. Yes, I don't like it myself. Okay, but that's up to you. If it is in DG exam or if we don't have access to exam.net, by the way, for the time being, I'm trying to convince the school to have that. But anyway, if you are comfortable with that, you can write it on DG exam or whatever. But I don't think it's a good idea. Okay, and then here, so you see I have this limit up to here, but in the last step, I have to get rid of it. So it means that now I replace x with 4, square root of 4 plus 2. And then this is 8. This is how much? 2 plus 2, 4. It's 32. And this is the important thing that you need to understand. So this was 0 over 0 somehow. Infinitesimal over infinitesimal, the answer turns out to be 32. And if you go back and look the examples we had before, every time that I'm calculating a limit with 0 over 0, I am getting a different answer. So this is why it is called indeterminate, because before doing the calculation, it is really not determined yet. You have to do the calculations. Depending on the behavior of the function, the number will come out. So you have to calculate that. Okay, so this was one problem containing important features. Factorization was included. Multiplying by the conjugate was also included. Any questions here? Okay, so let me give you another problem. Wait for you to solve it for me, okay? So number 2. So the limit, by the way, I am always using x as my variable, but that is not compulsory. What I do, I would say that the limit of t, for example, divided by 2 minus the square root of 4 minus t, I would send t to 0 this time. Okay, I want to wait for you so that you can solve it before I do it. Yes, yes.
Okay, so my first I got just 2 plus square root of 4 minus t, but then I thought I might be able to simplify it. So
No, the first, where do you start? Because this is one of those ones that contain a third sign, yes?
what I started with was just multiplying both the numerator and denominator with the 2 plus square root of 4 minus t.
Exactly. So this is, by the way, don't, in the exam, don't be lazy. You have to write it down once more and then show that you are taking this and multiplying it by 2 plus square root of 4 minus t, 2 plus square root of 4 minus t. Okay, and so if you want, I can also put a pair of brackets around. Again, then
Then I just put the numerator, I just put like t and then parentheses.
yeah, exactly. So you just juxtapose them. Don't do the multiplication because we want to factorize to simplify at the end.
And with the denominator, I multiplied them together so it became.
Don't multiply. Multiplication works, but use the conjugate pattern. That was the
Yeah, I meant use the conjugate.
Okay.
I turned it into it became 4 minus t.
But this, if you write, I don't know which way you have written. Did you write it like this?
Yes.
So this is wrong. Yes.
So you have to have 4 minus within brackets.
Yes, this is important. Or if you want to do it in one go, don't forget about this, put this minus sign for that one as well. So that was crucial. This is the reason that I put this on the right hand side to make this point clear. So t goes to 0, yes? Yes. And now the difference will be a minus sign because if you go a little bit further, I copy and paste the numerator. And then I open the pair of brackets. And then this 4 and minus 4 are gone. So this becomes the limit of t, 2 plus square root of 4 minus t, and then divided by t, t goes to 0. And now t and t are cancelled. Then it becomes the limit of 2 plus square root of 4 minus t, t goes to 0. This is the last step, so I have to drop the limit sign, and the answer becomes, which is 4. Yes? Yeah, understandable? Any questions? Yes?
You just had like let's say it was just a normal like equation, and you had 2 plus square root of 4 minus t. Did you simplify it by raising both of the factors to power 2, and you have?
No, you cannot do that. Because if you have one expression, so you see I didn't do that. Yes, you can if you want to. If you have just one single expression, I don't know, like this, you cannot raise it to power 2. If you are supposed to work with this one, you have to work with this one. Unless you have this equal to something else, and then in that case, when you raise this power 2, you should also raise that one to power 2, then you are allowed to keep the equality. So if I give you an expression without equality sign, if you raise it to power 2, it will not work, okay? Unless you remember that after the calculation is finished, you take a square root again. That is possible. But even in that case, don't have this wrong impression that this is 4 plus 4 minus t. This is not correct. The correct form is not only the first one squared plus the second one squared, but plus the 2 times the first one times the second one. So if you want to raise it to power 2, this is the correct way of raising it to power 2. If you just write that, that is wrong.
It's, yeah, I know it's, or I figured out it's wrong, but I didn't mean like put a bracket, so I just meant for each of the terms, but I realized that would like also.
Yeah, that's, yeah, I mean, for this one, you mean? Something like this, you mean?
No, I just meant that if you don't put brackets around, like you raise the 2 to power 2, then you raise the square root of 4 minus t to power 2. But I also realized that that would change the
Yeah, that's correct, yes. Yeah, you mean when I want to write here, from here to here, you mean?
No, like when you wrote just now, you wrote like brackets between the entire 2 plus square root of 4 minus t, and then put a 2 afterwards, right? Like a raised to power 2 afterwards, right there. You put
2 plus square root of 4 minus t.
yeah, and you put brackets around it, and then raised to power 2, right?
Yes, what I am doing is I am putting a pair of brackets around these two. So
Yes.
what you're saying is to put the pair of brackets around these two?
Yeah, but I just meant like yeah, exactly, like a 2 to power 2, and then square root 4 minus t, that to power 2. But I know that I realized that would also become a problem because it's not the same equation. But whatever.
Yeah, it is not a problem. It becomes 4 minus t.
Yeah, but like
The problem is because if you just write this and that is it, it is not complete. You also have to add this.
yeah, but that's when you put the brackets around the entire.
Yes.
That you make it into a conjugate pattern.
Yes.
But if I were to not have the brackets and just you start by having 2 plus.
So let me might be I don't understand exactly. If you multiply this by that, if I want to write every detail, I would write it like this.
Yeah, but
So I would say that the first one to power 2 minus the second one to power 2.
yeah,
Yes?
I was just thinking of exactly. I was just thinking about like nothing to do with this example.
Yes, I understand what you
Yeah,
mean.
but I realized that that would also like change the equation. It doesn't matter if you put brackets around the entire thing or take the term.
Yeah, that's what. So, but if are you talking about the negative sign or whatever? So the conjugate will always remain negative.
Yeah, I just meant that I didn't mean the brackets around the entire term, just around like raise each of the terms to power 2.
Okay, so let us make sure that you understand. Do you understand what I have
Yes,
written
yes,
here?
I understand it.
Okay.
I just was thinking about something else. Like
Okay.
But I realized something else.
Yeah, okay. But if you have any questions, you just come back to me and ask. Okay, but hopefully you understand what I have written is correct. Yes. Okay, so any questions regarding this? Let me write one more. I can give you a little bit harder one. Let us see how can you solve that. Yeah, this is probably optional. These are at the level of the lesson that you have. But let me also write another one. So square root of 1 plus x squared minus square root of 1 minus x squared. And then in the denominator we have x minus x squared. And I send x to 0. Okay. You can also think a little bit about this. So after you finish this one, you can also work here. So this is this example. Okay, and then I want you to solve this one and then we are done. Of course, I can also post this. This is for interested students. But I think number 11, after that, number 13, then we start solving them together, okay? I can make it a little bit bigger so that you can see it better. So 11 and 13. Does anyone have the answer to the first? Yes?
I got it to 0, but I'm not sure if it's correct.
No, 0 I don't think is correct. No answers, I will wait more. No answers? Okay, what happened? No answers?
Wait, can I just?
Okay, wait more. No, I'm just talking about 11. Yes? No answers yet for 11? It's not hard, the same strategy, but I have made it a little bit more complicated.
I'm rescaling it by the top one. I'm using the
And that's correct. You have to rescale it by the conjugate of the top one. Okay, I can wait more because this is not something hard. I wrote it optional. You actually lost motivation. Yeah, but this is not something actually hard. Yes?
1/2.
No. The reason I know it, I didn't calculate it. I put it in GeoGebra. Then after that, I want to teach you how to use GeoGebra to calculate limits as well. If I haven't typed anything wrong, GeoGebra provided me with another answer, with a different answer.
It doesn't look like I've done anything wrong, but I think
Just give me the answer.
No, I don't have an answer. That's the problem.
Okay.
Because what I like I get because I'm looking through it, I feel like I must have done something wrong if this doesn't, or I'm missing something.
If you get the answer wrong, you have to do it over and over and over again. This is the attitude. This is the correct attitude. If you just get the answer wrong and wait for me to solve it, you will not learn. You will learn it better than not listening to me, but it's not that efficient. You have to be stubborn if you want to learn something.
I think it's just gonna be one, but I don't know what.
No, still one is not correct.
Yeah, because
but you are very close.
What I'm getting is the numerator to 2x, which doesn't cancel with the. I'm always looking for a x minus x over 2 in the.
No, probably. Okay, let me see why this is making trouble for you. Yes, Absha? No. I told you I didn't calculate. I put it in GeoGebra. The answer is -1 according to GeoGebra. And then I want to calculate to see if I can get -1. And then I want also to teach you how to use GeoGebra as an actually essential tool for you. Okay, so what we do actually, let us try to solve this. I think you know the rule at least. That is good. So what I have to do, assume that this is an exam problem. I have to I shouldn't be lazy, so I have to rewrite this all over again. But of course, you have to rescale it. Because the first thing that you want to do, you want to get rid of the surd signs. And this is the first problem. I have given you 2 square roots on top. But the idea is the same. Hopefully you realize what to do. Okay, first tell me, do you want me to write the same denominator or do you want to do some changes to the denominator? You can do it step by step, but it is unnecessary to write so much. Can you foresee a little bit ahead of you? What do you think I will do with this? Yes? Factorize. So let us factor an x out. Instead of copy and pasting exactly the same thing, it doesn't hurt if I just factor it out. Because sooner or later, you, by experience, you know that you will need it. Okay? But how should I rescale it? Because surd signs here now appear in the numerator, so I focus in the numerator, and everyone hopefully agrees with me that what I have written is correct. Yeah, it is lengthy, but I don't call a lengthy problem a hard problem.
Is it not 1?
I don't know. I didn't if I haven't typed something wrong in GeoGebra, the answer should be -1. I will check it out.
Oh yeah, it's minus.
But tell me, is that understandable for everyone? It's a long expression, but not hard. Yeah, I'm just copying and pasting most of the time. Okay, but what happens? I go one step forward. So don't be in a hurry. I would recommend you. So the denominator, I just juxtapose them. So I would say 1 minus x and then that long expression. 1 plus x squared, and then I have plus 1 minus x plus x squared. Yeah, this is not hard. I'm just copy and paste. But what happens for the numerator, you know what happens, that because I intentionally made it in a way that it makes a conjugate pattern for me. So when I multiply these two, it becomes the first one to power 2, which will help me to get rid of the first third sign. And I will get 1 plus x squared. If you don't mind, let me just be patient. And then always minus sign, and then the second one squared, which will help me to get rid of the second third sign, which becomes 1 minus x plus x squared. So do you agree with me so far? And then of course x goes to 0. And I think everyone knows what is the next step. What is the next step? The next step is not touching the denominator. Yes, just keep it like this because it is already written in the factorized form. It's a product. So copy and paste. It is lengthy but not hard. I want to differentiate these two. Hard math problems are not the ones that are very lengthy. They are the ones that you don't know what to do. Those are hard problems. Okay, so this becomes the limit. I copy and paste the denominator. Okay, and then I remove the pairs of brackets. For the first one, you don't need to be careful at all. Nothing is behind that. But for this one, you have to be careful. This minus sign is not only for the first one, but for all the terms. Yes? Yes or no?
Yes.
Okay. And then the next step is, of course, simplification if possible. So just copy and paste. You see, it is lengthy, but copy and pasting most of the time. Okay, so this one and that one are cancelled. X squared and x squared are cancelled. So this x and x becomes 2x.
Doesn't this just become 1?
And then what happens? This x simplifies. You are right, the answer should be 1.
Yeah, so where's the minus sign?
No, I don't know. Might be I have typed that wrong in the GeoGebra. Let us see. So this x and that x are gone. Okay? So let me not be lazy, just one more time. And then x goes to 0. Now everything is fine. If I'll have to replace x with 0, the numerator is 2, the denominator is 1 minus 0, square root of 1 plus 0 to power 2, plus square root of 1 minus 0 plus 0 to power 2. By the way, you really don't need to write this part. Okay? But it's extremely important. You have to drop the limit sign at the very last stage. Okay, so what's the answer? 0, 0, square root of 1, 1. Remember, this is 1. That is also 1. 1 plus 1 is 2. 2 times 1 is 2. 2 over 2 is 1. So I don't know. Did you say 1, I think?
No, I said.
Okay, but anyway, so let us go to GeoGebra to see how it works in GeoGebra.
GeoGebra gets 1.
Gets 1? So I should have mistyped that. Okay. So here I go to GeoGebra. That's also good to know. As usual, I go to CAS view to calculate symbolically. It's better to go to CAS view, and let me just get rid of this graphic view, which we don't need. And then let us try to type limit. Okay, so there are, by the way, there are 3 words that you see. Limit above, what do you think this is? Yeah, the one that I put a small positive on top. Limit from the right, or they are calling limit from above. Limit from below. But my point is not this. I want to calculate the limit. And there are 2 things happening here. I want to also explain why they have two options: limit expression value, limit expression variable value. Okay, so let me just choose the first one because I have my expression and I have my value. Okay, so what is my expression? I have to type that long expression. So I open a pair of brackets and then I choose this square root of 1 plus x to power 2. I go outside. Is it 2? Yes. And then I have a minus sign there. Again, I have a square root of 1 minus x plus x to power 2. I go outside and then I divide by x minus x to power 2. And then what the value is? What should I put for the value? The value is this number, where x is going to, okay? So I have to choose 0 for the value. Okay, so this expression that you see in GeoGebra is exactly what I have here. And then when we actually ask the GeoGebra, okay, might be I was confused because of this. I am getting old, yeah. Yeah. Yes.
So if you write x goes to 0 in GeoGebra, it interprets that as a logical operation for some reason.
Oh, I don't know about that.
No, it returns just true.
Uh-huh.
In the limit function, it's just a question.
Oh, okay, I didn't know about that. So what should I write? You mean just type the limit and say 0 goes?
Instead of 0,
Yes.
write x goes to.
Goes means by English words, you mean?
No.
By this arrow?
Yeah, so it's dash.
Ah, okay, I understand what you mean. Let us check. So you mean that I put x and then I put this dash, where is it on my computer? Here, and then this sign, yes?
Yes.
And then 0. Of course, this is of good. Yeah, let us see what happens then. Question mark for me. Yeah. Okay, but this is not the correct syntax. But you can use in Alpha Wolfram because that is based on AI. Probably that person, that software will understand what is your meaning. Yes.
So,
But what was the question? There is no question. Yes.
No, it's just like weird syntax.
Okay. Yes.
so if there are multiple variables in like an equation, if you're trying to calculate the limit of a
Yeah, I will. I want to talk a little bit about that point in the board. So here, I don't know if I switched to GeoGebra view or not, but anyway. So here, one thing that I want to mention, can you just tell me, this is a very simple question. If I ask you what is the limit of x to power 2, just x to power 2, x goes to 5. What's the answer? What's the answer? 25. One thing that I want you to mention is that what is called, this x is called a dummy variable. What does it mean? In mathematics, when you say a variable is dummy, it means that when you replace that variable everywhere in the problem with another letter, the answer is still the same, And that is clear, because if I decide I don't like letter X for some reason, I change it to letter Z, but I change it everywhere, here and here. Every appearance of X is now replaced with Z. What will be the answer to this limit now? 25. So you see that this is what we call that the limit variable is a dummy variable, meaning that if you replace that variable everywhere with another variable, you will not affect the result. That is one thing. Another thing is that you might have different letters. Yes?
Is it not the same with like any equation if you just change the letter to another letter? Because like
No, that is different. Because if I write x plus 2 equals to 3, if I ask you to solve this, you get x equals to 1. But if I replace this, the roots, of course, are not there, but you just get this t equal to 1. But here it's not. If I ask you what is the answer to this, what you put here is 25. Regardless of if it is expressed in x or if it is expressed in. But if I give you this and ask you what is the solution, for this one you say t equals to 1, you say that, yes.
is it because you have to specify with the other equation here that it is t that you're like
Yeah, exactly.
but if it's only like one variable
Yeah. Yeah. But in the limit, it doesn't really matter at all. because the answer that you are giving to me, if I put a question mark in front, you just write 25. If I write a question mark in front, you just write 25. Yes?
So essentially, in the question, when it comes to changing the dummy variable and limits, the dummy variable is essentially just an empty box while in the other one with the equations x plus 2 equals to 3 and t plus 2 equals to 3.
You need to also express the letter, the variable name.
Because we implied that they are something, that they aren't the same thing.
Yes.
By
Yeah.
labeling them something different.
Yes, yes. So what happens with this? Oh, the battery is changing, so it's really inefficient microphone. Okay, but anyway, this is one thing. Another thing is that, oh, this will make a problem for us now. Okay, so I have to speak a little bit louder for the last part of the lesson. So now assume that we have more than one variable. That is the reason that they have another syntax in GeoGebra. Might be I ask you this question, the limit, let me write something, and this will appear in the next chapter. So when I'm talking about derivatives. For example, I write 2x plus 5h, and then I write x goes to 0. How many variables you see here? I see two variables apparently, but one of them is not variable when it comes to this limit. Which one is variable for the limit? X. Because I am making x closer and closer to 0. I don't have any leverage to change this h. Someone has already decided about the value of h. For that particular value of h, I am supposed to calculate this limit. So what will be the answer to this limit? Can you tell me?
5h.
It becomes 5h. And then if I ask you what is this limit?
2h.
In this time I send h to 0. Now the variable for the limit is h. What is the answer?
2h.
2x. So you see, this is also happening. This is why GeoGebra is asking you, especially when it comes to the next chapter, the derivative. We have x and h simultaneously in our limit. Yes, please.
So can you write like two variables and send them to a limit?
Yeah, but that would be a university lesson, because that would be a function of more than one variable. But here, you don't consider this a function of more than variable. It means that as far as this limit is concerned, someone has already fixed the value of h. Which value we don't know, but that is fixed. What is not fixed is this x. I am just making x closer and closer to 0. Here I am, someone has already fixed x, but I am making h closer and closer to 0. So this is why when you go back to GeoGebra, you see when I type limit, you will have, when I go to just limit part, I have to do this. For example, let me just do this one. If I just type 2x plus 5h, okay, and then you need to give the name of the variable. Here I have 2. Let me choose, for example, h as the variable. I want to do the second one. So I will choose the variable is h, and I want to send h to 0, so I will choose 0. So what is the answer? The answer is 2x. Yes? Is it so small? I don't know. This Control T doesn't work here. Anyway. Yes?
Like when doing multiple variable limits, can we have two variables approaching a number?
Yeah, that's what he asked actually.
Okay.
Yes, in that case, that's the point. Because when you go to higher dimensions, your function would be a function of more than one variable. And then when you are going close to a point, that point simultaneously involves with different variables, x and different coordinates. So that would be a harder concept. But that is completely conceivable. So is that clear now? So the notion of the dummy variable and the notion if you have more than one variable. And then let me ask you one question immediately here. What do you think? So of course I want to change this back. I want to say 0. Okay, and then you know the answer is as before 1. Okay, do you think if what happens if I type the same expression but in this syntax? I don't know. Do you know a better way to copy and paste things in GeoGebra?
Control C.
Control. I just want to highlight. Okay, they have actually updated. So Control C. Then I come here and let me start type limit. I want to choose limit above, but I want you to guess what happens. Okay, I choose limit above expression value, and I press this one, and I control V, and then typing inside is the same, but the notions are different. So I put this 0. In my handwriting notation, if I want to write what I wrote on GeoGebra now, I have to write the same thing. I have to write, so I am asking you what is the answer to this. In GeoGebra, they don't have this symbol. They are talking about limit above, limit below, or some softwares might ask you limit right, limit left. That's the same thing. So now, before I press the execute button, I want you to answer what will happen for the answer.
The answer will be 1.
What is your answer?
It will be the same.
Why?
Because you said before that if the limit of both directions is one number, then both directions have to be the same.
The same. So because we already calculated the two-sided limit without considering which direction we are approaching to 0, and we got that one is equal to 1, so this guarantees that the left limit, the right limit should be 1. And let us check it, yes. So when you check it, that is exactly equal to 1 again. And I really want you to use any software. I think GeoGebra is because free is very good. Please try to learn how to use it properly, yes?
So how do you test like numerically or how if it's the same limit like from?
Okay, so in that case I don't know, but in I don't know, in Python it is simple. You take your function, you make a table of values, and then give the values for, I mean, in programming language, this is also possible. I don't know, might be you can also make a table out of values, yes? In any way that you can make a table, so then you choose some values for x which are close to 0, and then ask GeoGebra or any coding system or something that to generate the values. And then you should see that those values are approaching to value 1 when you are making your values of x close to 0. Yes. Yes, please.
Of course, it's great to learn GeoGebra, but test-wise, will we ever like have a question where you will ask us to like write?
No, in national exam, yes.
Okay.
That's the reason that I really want you to learn GeoGebra, because I will ask the school to make it happen for you so that you can have access to GeoGebra for the exam, national exam. And last time I realized they intentionally make some questions, even I don't know how to solve them without software. For example, if you give me a fifth degree equation, I don't know. There is no one knows. Yes, so you have to be able to. But if you give me GeoGebra, I know what to do to get the answer.
So the important thing is that we just know how to punch in a specific.
Yeah, but that is sometimes not easy.
Yeah.
For example, if you remember, I was also confused. For example, I didn't know that I have to put the product sign there. Yes, so these are the things that you have to really practice about. Okay, so that is also the notion of the limit. By the way, that might be fun if we can see what is the what is the graph of this one. By the way, do you expect any kind of discontinuity in this complicated function? No? Okay, let me ask you one question. Let me go back to the board and ask you, what do you think will be the result if x goes to 1? Let me ask you one question. This function is complicated. I really don't know the graph, how the graph looks like. Okay? But let me ask you one question. Do you expect... So if I ask you what is f of 0, what is your answer? This function, I give you this function. Instead of asking you about the limit when x goes to 0, I ask you what is the value of this function at 0. What is your answer? Undefined. Okay? So this function is not defined at 0. Okay? But I calculated the limit, and the limit is actually what? 1. So what do you expect in the graph of this function to happen close to 1? Close to 0. I don't know what will happen in the other points, but I know something about 0. Is the function continuous at 0? The function is continuous or not?
At 0.
Yes.
No, because it's
No, because even though the limit exists and is 1, the function doesn't have any value there. But you cannot see it with the naked eye on GeoGebra. Why? Because there is only one point carved out from the graph.
infinitely small.
Yes? But you cannot see that. And then you feel it is continuous.
Yeah.
So I mean that even if you have GeoGebra, you cannot see it with your eyes that this is discontinuous. But mathematically, you know it's not continuous. There's one single point missing. Okay? Okay, let me ask you another question. What do you think will happen if I send x to 1 instead of 0?
For a limit or function.
No, limit. Again, so what happens for the function at 1?
It's undefined.
It is still undefined because the denominator vanishes. But if I send x to 1, everything remains in. So if I put 1, what happens? What do you think will happen?
The limit.
Yes. No, I just want you to understand the behavior. The denominator approaches 0. Why? Because if it is 1, this would be very close to 1, very close to 1. The difference would be very close to 0. But what happens for the numerator? When x is equal to 1, this is gone. I get 1. Remember that. If I put 1 here, I get a square root of 3. So in practice, I get something strange like this. Okay? But be careful, not exactly square root of 3, approximate, very close to a square root of 3, very close to 1, and infinitesimal, very close to 0. So it is not meaningless when I want to calculate the limit. Yes? It is not meaningless when I want to calculate the limit. So, but what happens now? It becomes a number that I am dividing it by a very, very small number. Yes, the number in the numerator is, I don't know, around 0.7 something, but the denominator is extremely small. And if you divide a number which is finite by extremely small number, what do you expect?
Infinite.
You get an infinite value. But then, what type of infinity? Is it an infinitely positive large value or infinitely negative large value?
Depends on where you
Yeah, depends, exactly. Depends in which direction you are getting close to 1. Because if this negligible value is less than 0, you get a huge negative number. If this is negligible number is positive, a little bit positive, then you get a huge positive number. Yes? So I don't know if this is instructive or not. We can actually go to graphic view to see if, of course, this function is too complicated. Might be this is not a good example of what I'm supposed to do. But let me just see y equals to, so Control V, yes? Okay, so let us see what happens. GeoGebra doesn't answer anything.
You need to
Yeah.
change view.
Yeah, might be. So what?
It's fx. And then
Okay. I should go to
graph.
so it is in graphics view, isn't it?
Okay, yeah, then it's just yeah.
No, graphic 2 probably. Algebra. Might be in algebra. Huh?
I don't know.
So let me just put algebra here.
It's f.
Y equals to Control V. Yeah, that's the graph. Okay. So so this is the graph of that function. It's not, by the way, that complicated. But at least you see this point around 0, you know that this is not correct. So let me zoom in because I just care about what is happening around 0. Here is x equals to 0. The function seems very smooth. It is smooth, but this point should be carved out because the function is not defined at 0. But nothing except that is happening because the limit was 1. And this is also predicting, you see, yes?
So if you go up in the algebra table, no, left.
Here?
Yeah.
Yeah.
And just click it once.
Here.
Okay. Anyway, for me it highlights the discontinuity.
Oh, really?
Yeah. Like you get a little dot.
But might be, so it's not working here. So
Different
so
graph.
can I see it? Can I see it there? So you cannot see it in the version that I have. And this is good to understand. So you see, nothing strange happens there. And by the way, there is also a nice feature. You see, it was a curve, but if I look it locally, it seems flat. And that's exactly what's happening with the Earth. Still, some people believe that the Earth is flat. Yes? And that's exactly the same thing. If I showed this picture to you before, you would say that this is a straight line. But apparently, if you have a bird view, it's not in line at all. It's just a curve. Yes? Okay, so yeah, I mean, these are the analytical work that we can, because if someone give me the graph, this is not hard. If I, by the way, if I had given you the graph before giving you the function, and I ask you the same question, what is the limit when x goes to 0? You should be able to answer to me using this picture. Yes, is that clear? How? Because you would say that, for example, I am here. The height is this much. So let me highlight this. Whenever I need something, it's not there, but anyway. Okay, so here you have this height. You become closer, the height increases. You become closer, the height increases. But when I am very, very close to 0, the height will be approximately equal to 1. And it doesn't matter if I am approaching to 0 from the left or I'm approaching from 0 to 0 from the right. I will get that one. Okay, any questions? Yeah, so that is, I would say, the end of the lesson here. But this is also a behavior. What do you think is happening here? That one, what we predicted. You see, this number, let me just draw x equals to 1. This is x equals to 1. Yes, so what is happening? When I am on the left-hand side of 1, the function is extremely big. It's actually growing very big. Do you see that? So it's going up. So that is the reason. When I get close to 1 from the left, the function is going to infinity. And when I am getting close to 1, but from the right-hand side, the function is actually going down. Infinitely a small number, minus infinity. So that behavior, we will study a little bit in Math 4. This is something given in your book, but not complete. Anyway, questions? Okay, so this is the end of what you need to know for the coming exam next week this time, yes? Starting in the beginning of this session.